Here's our video for example 0. This is to show you how to plan, organize, and show your work during the design process. And it is a design process, and that's one thing I really want to make sure that we get in this class, is that this whole thing is a large process. The design isn't just drawing the picture and saying, doesn't this look like a nice product if we were to make it? That's just your hopes and dreams of what the final product would look like. But really, we have to make sure that everything up until what it looks like gets completed. The inner workings of it, we have to make sure that it's tested and that it does everything that it needs to do. And that takes time. A lot of things are going to take months, if not years, during the design process. For smaller things, such as projects, those are going to take weeks, and that's why I'm giving you weeks to work on them. And things like your homework are going to take hours, if not maybe a couple days to complete. Not 8-hour full days, but it's going to take some time to complete. But what I want you to do is I want you to use the design process, at least some of the things that we're going to talk about today, to complete things like your homework. Even if a homework is somewhat on the simpler side and you say to yourself, I don't need to necessarily go through all these steps, I want you to, for the sake of learning how to go through the steps on something that isn't quite as challenging, so that when you get to something more challenging, you can go ahead and already know how to use some of these steps. All right, so some things that we're going to do, and I'm just going to actually scroll through really quick because I know that if you're taking my class, you have access to my notes here. But if you don't, then you're going to need to maybe pause at a couple different spots so that you can see what's happening. Maybe go ahead and read it a little bit closer. This is really just going to be an overview. So once I get down to the bottom, we'll hop back up to the top and we will talk about kind of where to go from here. All right. We're going to talk about top-down design, bottom-up design, flowchart, and pseudocode. And then as far as pseudocode goes, as far as how we can make things happen, we have what we call control structures, and that's how we can piece things together. So first off, with a top-down design, it means that I'm going to break things apart. It means that I'm going to start with a large problem. It means that I'm going to break it up into some smaller pieces. And I'm going to take those smaller pieces and I'm going to break those up again. And so at this point, because people know how cars work, cars have been around for well over 100 years, what we can do is we can say, all right, if I want to build a car, I know that I'm going to have to do certain things with it. I know that we're going to have a frame and a chassis and all the stuff that goes along with that. I know that I'm going to need the engine and the transmission, the drivetrain, and all the stuff that gets the power from the engine to the wheels. And I also know that I'm going to have maybe some other stuff, maybe some of the interior stuff, or maybe this is going to be some of the sensors, maybe it's going to be the steering systems, something along those lines. But however you break it up, what you're going to do is you're going to break it up into pieces. Then what you're going to do is you're going to say, all right, so I'm going to break that up again. So let's say that this first thing I broke up was how to get power from my engine all the way down to my wheel. So this is kind of like my power system here, my drivetrain and everything. We need to look at how can we break that up. Well, I have my engine, I have my transmission and my clutch, and I have my drivetrain and differentials and all that stuff. What I can do is I can then break that up again. I can break that up into different pieces all along the way until I've broken it up 100, 200, 1,000 times, whatever it needs to be, where the very bottom are going to be very, very simple tasks. Now, I might have a lot of those simple tasks, but what we have is they're at least more simple to do. And that's nice, especially if you're working in a team, is you can start assigning some of those small tasks out. And as those tasks get completed, we can reassemble them until we have our final product, which might be building a car. We have a bottom-up design. Bottom-up design is the opposite. We start at the bottom and we say something like, hey, look what I invented. I invented an engine. That's cool. What can we do with this? And we can do all kinds of stuff. We can say, well, I can do this with it. I can use it as a heater. I can use it to spin things. I can use it to do this. I can use it to do that. And you say, all right, well, what if we were to attach some wheels to it? What would happen? What if we were to then put 4 wheels onto it? What if we were to attach a clutch to it? What if we were to attach transmission? What if we were to attach it to a frame? What if we were to attach it, put seats in it? And what if we were to put a windshield on it and all that stuff? Eventually you might get to the car that you might want, but what you're doing is you're just kind of building from piece to piece. You're building from the bottom and you're just kind of spreading out until you get what you want done. So what are some main differences here? Top down is more structured from the beginning, where the bottom up is more experimental. The top down, I will probably need fewer iterations to get the final product. That doesn't mean that I'll just have a few. You can still have multiple dozens, if not hundreds, of prototypes. But with the bottom up, you could have more than that because you're just kind of testing things and just trying things out. Top down, you're going to spend a lot more time maybe on paper getting things organized first. Bottom up, it's going to be more hands-on, but that can cost more because building things not only takes time, but it also takes more materials. So both of them are useful. And we can't always just say, I only do this type or I only do that type. You're going to want to be able to use both. And I do have students, so here's a word of warning. There are some students that really claim to be hands-on and they say, I don't like bottom up, I don't like top down, I just like to get my hands dirty and get things done. And that's fine to a point, but remember, top-down designs are still important. The other thing is, if you want to do a bottom-up approach, it does mean there's going to be a lot of work. You'll probably need to do 10 times more iterations, 10 times more codes, 10 times more circuits, 10 times more builds, because since it's more experimental, it's going to go through all those things, where if you're doing it on paper, you're getting a bunch of stuff worked out before you actually do the build. So you still might have, a dozen different ways of doing something, but that was only on paper. You can cross a lot of those things off before you actually get to the actual build. So top-down designs, a lot of work on paper, getting some of this easier stuff figured out on paper before you move on to the actual builds, get things nice and organized. Bottom up, you're kind of just trying things out and seeing what happens. Sometimes you end up in a good direction, sometimes you don't. You have to start completely over, or you just have complete dead ends. All right, once you have all these different pieces that you've come up with, whether it was from a top-down or a bottom-up design, what you can do is you can put all those little pieces into a flow chart, all these little ending pieces at the very ends of our sub-problems or our sub-problems, whatever it is. I can take those little pieces and I can start putting them in some type of order. And I do that with a flow chart. I can then turn that flow chart, which is very visual, I can then turn that into a list of things, more like a recipe, something that is step by step and more maybe text-based. All right, so when I take all those little pieces and I turn it into a flow chart or into a pseudocode, I really have 3 ways to do that. I have 3 control structures. The first one's called a sequence structure. What it means is it goes one step, then the next, then the next, then the next. If I want to make a sandwich, I need to get the materials out. Then I need to open everything up, then I need to assemble it, then I need to put stuff away. I should actually probably break that up into smaller and smaller pieces, such as, how to open up this jar compared to how to open up this bag of bread, how much peanut butter to spread on it, or what type of jam to get out, or whatever type of sandwich. If you're making a ham sandwich or a turkey sandwich, how much to get out, how to lay it on there, whether you just kind of slap it on there or whether you fold the pieces of meat, whatever you want, step by step. To make a sandwich that takes 2 minutes to make, you could have 100 or more steps, 1,000 steps of little things that you're doing along the way, but everything's in a sequence. Do this. As soon as you're done, then you do this, then you do this, then you do this. The next one's going to be a selection structure. With a selection structure, I actually have 2 pictures here. But what we do is, before I get to the selection structure, I might have a sequence that's happening, but then I get to a branch. I need to figure out whether I'm going to do one thing or whether I'm going to do the next. Am I going to make half a sandwich or going to make, is that false? Am I making a whole sandwich? Am I making a ham and cheese sandwich, or am I making a peanut butter and jelly sandwich? And so what I have here is I have a branch where things are going to differ a little bit, and that's a selection structure. Within the selection structure, you can see that I can still have some sequences. I have two different versions here. One where if it's true, I have a sequence of things to do. If it's false, I have a sequence of things to do. Eventually, we come back together. I have another one here where if it's true, I do some stuff. If it's false, I just jump back down here and we continue on later. This would be like if you're making a ham and cheese sandwich and you decide to put tomatoes on it. If that's true, then you have to get out the tomatoes, you have to slice it, you have to set it on there, blah, 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 blah. If not, we'll just skip that step completely and move on. All right, we got a repetition structure. This is our last structure. This is if I'm going to repeat something over and over again. If something is true, go ahead and do some stuff, then we come back up here and we check again. If it's still true, we're going to do it again, and we're going to keep doing that until it's false. Once it's false, we're then allowed to get out of here and we're allowed to move on. Let's say that I'm making 10 sandwiches for me and my friends. If I have less than 10 sandwiches, that's true, make another sandwich. If I have less than 10 sandwiches, make another one. I'm going to do that until I come up here and it says, do you have less than 10 sandwiches? Well, that's false. No, I don't. Or yes, I do. I have more than 10. I'm going to hop over here and then I can move on. I can, go give the sandwiches to people. All right, so the example problem here is we're going to make a top-down design, a flowchart, and pseudocode of how you would exit a room. Now, since I'm the one designing this, this is my room. In my situation, I know that all people are different, all rooms are different, all situations are different. This is me leaving this room that I'm in right now. There's no door, there's nothing blocking me from getting out. There's nothing I got to do. I don't need to know how to, turn a doorknob, any of that stuff. Seems like a pretty simple thing, but the problem here is exiting a room, and I can still break that up into pieces. I broke that up into, do I know how to stand, do I know how to walk, and do I know how to find an exit? That's how I'm exiting my room. As far as standing goes, you can say that's easy enough, know how to do that, but I can still break that up into little pieces. Standing, put your feet on the ground, put your weight over your feet, push yourself up. How to walk. Do I know how to alternate one foot from the other? Lift a foot, move a foot forward, set a foot down. Can I find an exit? Can I open my eyes, turn and rotate, and can I recognize the exit? So now I've broken this up. I have 10 things that are going to make me able to exit the room. That doesn't mean that if I do this and then this and then this and then this and this one step at a time, I'm going to be out of the room. I still need to put these in some type of order. Now, if I decided instead of doing a top-down design, I did a bottom-up, what would that look like? Well, I'd start at the bottom. Hey, look, I learned how to put my feet on the ground. That's cool. What can I do because my feet are on the ground? Well, I can stomp my feet, or I can leave them in one spot. Well, let's travel up this leave them in one spot branch. All right, now if I'm leaving them in one spot, what can I do? Well, I can rest them. I could probably do some other things with them, or I could put my weight over my feet. That's cool. Let's travel up that one. All right, I can stay sitting even if I put my weight over my feet, or I could push myself up. And what you can do is you can say, okay, what can I do here? Well, I could work out. I could do some squats, or I could stand. But you can see that there's a lot of room for kind of evolution and different directions of things to go, which is why sometimes it takes a very long time, because you're just kind of trying things and see what happens. All right, so I chose to go ahead and use my 10 things from my top-down design. And what I've done is I put them in a flowchart. So the only thing that are actions in this flowchart are those 10 things that I've written down at the very bottom of my top-down design. Now, I have written a couple other things in here because what I did was I asked some questions. I put my questions in as diamonds, and so I ask if I'm standing. If that's false, this is a selection structure. I can go over here and I have this sequence of how to get into a standing position. Either way, whether I was standing to begin with or whether I had to go and stand, The next step is I open my eyes. Once I open my eyes, I ask this question, and I've worded it kind of weird because I found that it works a little bit better with the explanation. My question is, if I don't see the door. If I don't see the door, that's true, then I turn and rotate, and I keep doing that. This is a repetition structure until I do see the door, and then I can move on. I ask another question, have I exited? If that's false, if I have not exited, then I do my walk. I lift a foot, move a foot, set a foot down, alternate my feet. I come up and I say, have I exited if I haven't? Well, I do that process over and over again until it's true that I've exited. Now, if I wanted to, I could add something else on here. All right, now that I've exited my room, let's cook dinner. Now that I've exited my room, let's go to work. Now I can do my homework. Whatever it is, I can add that on. So this is my visual representation of what's happening, which is nice. But at a certain point, we need a list of instructions often as well, especially if we're going to code this. So what we're going to do is I'm going to figure out how to make it look more like code or a list of instructions. I call that pseudocode. And so I write out each step. And what to do in the case of needing to do that step. Now I reworded this here. Initially I asked if I was standing. I changed that for if I wasn't standing. So that might be a little confusing looking from my flowchart to this. But we can go through, and if any of these things are false, I can just hop over them. If I'm not standing, if that's true, then I do these things. If I'm already standing, I can just hop down to the next step, hop down to the next step. If I see the door immediately, I don't need to turn and rotate. I hop down to the next step. So that is how to begin breaking apart an idea so that we can organize it into a product or a prototype or whatever else we need to design.